This presentation was made about a month or so ago with at the National Convention of ARCSA, American Rainwater Catchment Association. Um, I'm Bob Boulware. I'm a retired engineer. Marcus Linger is a PhD microbiologist and engineer, and his company Clean Blue uses microbes for processing the grease traps in restaurants. Yeah, and Billy Kniffen is retired from Texas A&M. He was with the Texas AgriLife and was really one of the major proponents of rainwater catchment in Texas. And we all uh, got together and made a presentation. What we talked about is, in addition to the rainwater sanitation charges, what are the problems? Some basic recommended design components. Marcus talked about the mechanics of the biofilm, and then Billy talked about some of the projects that he had worked on in Africa and Tanzania that apply what we're talking about here. Um, the As you know, there's a lot of people in the world that need water, and with pollution and things, the asset that we have, which some of the numbers are like less than 1% of the world's water is available fresh water for use. Um, and that's a diminishing asset as we have increasing pollution. Uh, Coupled with the problem that we've got increasing population, we've got increasing demand on that asset, and then also too we can't forget that a lot of the really icky diseases are waterborne diseases. So that's kind of why we see the importance of this. Recently in Stockholm, they had the World Water Conference where, interestingly enough, they talk about food, energy, and water security. But interesting about how the water issue also contributes to food security in countries. Um, the United Nations also is active. They have their strategic design goal or development goal 6 for water. I was fortunate to attend with my colleagues for International Rain Harvesting Alliance out of Geneva in the 2023 convention. And that's where I learned the length and breadth of how international the problem of clean water is. And about that time was when we got involved with Data Raywall there in Nepal, and which kind of put an underscore of the issue. Um, 20 years ago, we saw in this country emerging droughts, and we had some colleagues from Australia that were members. So what we did, we gathered up all the good ideas we could from around the country, around the world, and we put together a rainwater guideline. That got the attention of some of the code writing bodies, which are basically the people that write the rules for plumbing system in the country, and IAPMO basically being our chief supporter in that regard. And that what we end up doing on that is having the benefits of first flush to kind of get the best quality water going in as we could, and then uh, trying to come up with alternatives to chlorine and some of the harsher chemicals that use like ultraviolet light and things like that. And that was quite successful. It's now a reference document, and we can say that we've almost created an industry here in the U.S. of rainwater catchment now that we've kind of established rules that will provide reasonably safe water. Okay, but what about the people that are off the grid that don't have any access to power and some of the technology that we in the West have? And that's what kind of drove the need for our off-grid standard, reflecting that some of the work that Data Raywall is doing in Nepal for his people. Um, so. So the first thing was a first flush, try and get the water. We've done a lot of papers. I read a lot of papers when we developed this thing, and the common thread is that there's a lot of debris that comes off the roof, fecal matter and such that causes diarrhea and a lot of other diseases. So the intent is, okay, let's clean the water up as best we can. Um, and this is the simplest version right over here, just a dead piece of pipe. And then you basically put like a drain at the bottom, or even like a 16th inch 2 millimeter hole that it'll automatically drain. But then when the dirty water fills up, presumably then the clean water overflows and goes into your cistern. A better version of is a more high tech that has like a 400 mesh filter. And then what we have here is a more elaborate one. It's a German product where the water comes in the top. It goes straight through when the screen is dry, taking all the dirty water and the sticks and stones and leaves. But then after a while, the water saturates the screen, and then capillary action takes it to the outer area, and then that then goes to your cistern, and it's a more appropriate for larger systems, schools, hospitals, and that sort of thing. Um, we couple that with kind of what we learned the best ways of going in and out of a water tank. We come in, we have indirect at the bottom there to kind of keep from stirring up the anaerobic and the sediment at the bottom. We like a floating inlet. We'll talk about this a little bit later about how the best water is just right below the surface of the water. And this is what we call a skimming overflow here, excuse me, a vacuum overflow, which basically, when the water gets up, it kind of draws some of the debris and sediment off the bottom of the tank. And we'll talk a little bit more about that. The key to this is you need to have a hole up at the top there to keep siphoning the water out. But it does a good job of keeping the bottom of your tank reasonably clean. Um, these are the water standards that we try to aim for here in the West. Nothing new, but coincidentally, we're very similar. You can see up the top here. That's the you know, same as the World Health Organization standards for fecal and that kind of thing. The East and the West are on the same page in that regard. Biofilm is probably something that everybody in the world is already using. Maybe they know about it, maybe they don't, but it's a natural process, commonly relied upon internal mechanisms to be adequate as a water sanitation mechanism. Um, it's basically adds what ARCSA has already learned regarding as a supplement to the first flush or a component of the first flush to maximize the water quality into the system. The thought being the better quality into the water, the less work the biofilm has to do and the better quality of water out. And the results have shown that it does a very good job as not only as a primary device or even to a more sophisticated sanitation method, but also a standalone in some regards. The mechanics of the biofilm, it begins to grow, it matures, then it basically sloughs off. And this basically, as we talked about, it falls to the bottom, and this is where your vacuum overflow would come in. As it falls off the bottom, that debris will come off and be drawn to waste and keeping your water quality clean. Um, this all comes from about 20 years ago. I sat in on a presentation with Peter Coombs, who's Newcastle University out of Australia. And he basically, you can see his tank right here. Um, now, he did not believe in the first flush, but he did amplify the need to keep your roof clean. And what he found out on the water quality is that the coming off the roof, this is what you get at the tank surface. You get where the oxygen is. Yes, it does increase a little bit, but at the tank outlet, you could see the coliform diminishes, and this speaks to the work being done by the biofilm. The hot water basically is presumed to be heated to 140 degrees Fahrenheit, which I believe is about 60 degrees centigrade. And once it gets up to that temperature, it's presumed to eliminate all, or at least most of the harmful bacteria that you'll find in water. As you see going down the list here, the heteroscopic plate count, I struggle with that. you can see even there that the work of the biofilm diminishes that. And even down to the bottom here, even you can see how the biofilm works to reduce the heavy metals that might be occur in your piping. Um, this is another example of this is what you would call uh, the clean tank, quote unquote. Okay, where you basically come in, you scrub the biofilm away, but and you can see uh, that it doesn't really help that much compared to the bottom line here, where you can see the biofilm actually within a matter of hours can reduce maybe 40% of the heavy metals that are in the water. So this speaks to the work of the biofilm effectiveness. Um, as a side note, why do we want the floating inlet? Uh, as you can see here at the surface, you have this level of thing, but and at the bottom you have this level of contaminants. But at the middle, right below the surface, you can see the benefits of drawing water off below the surface of the water. Um, and again, this speaks to the benefits of heating the water um, to further diminish the bacteria. This is the work of Muyan Han. I met Dr. Han at the UN conference back in 2023. Was impressed with his work and have kind of been following it. And Dr. Han basically does exactly what we're talking about here. He took advantage of the biofilm in uh, as done by Peter Coombs in Australia, but he added the first flush that basically allows the water to be clean before it goes in, and then is distributed throughout the building afterwards. And he uses the sequential tanks, which uh, basically adds additional surface to allow the biofilm to progressively improve the water. As a early research, he basically put a lot of small cards, 3 by 5 inch card on fishing string, and strung them in a tank to provide additional um, surfaces for biofilm to grow. And this is probably a more evolved methodology that he came doing the same thing only with sequential tanks rather than small cards. You could see the effectiveness of this. This is a school in Phnom Penh, Cambodia, and you can see down at the bottom that yes, it passes the World Health Organization water quality exam. If you have a public system, or just for some reason you may need a better quality water, then these are some options. Sand filters have been around since Roman times. Again, you can talk about boiling the water. If you've got some solar available, you can basically use this is a 20 micron, then progressively a 5 micron, and then the UV component there that provides the sanitation of the water. So now this is Marcus Linger's component, so I'll do my best on this. The intent of what he was wanting to do is explain to the U.S. crowd that they basically have the opinion that biofilm is bad in plumbing piping systems, and here we come along and say, well, biofilm is good in rainwater systems. So his mission was kind of try to explain what the difference is, and this is kind of the life cycle of a biofilm. Attachment, initial colonization, it has this membrane that it grows, and then it matures. Uh, and I'll just skim through this and let you read it as you go. He basically does a good job of explaining it. Um, Again, this is where it kind of starts. Um, Colonization, they kind of multiply themselves. And this is kind of where the magic happens, I guess, is that they kind of make this resilient glue around the process, but create their own little microbe community. and they then basically feed on the bacteria and the heavy metal that you're likely to see in the water.
And so,
And
why is that bad in a commercial system versus the off-grid system?
that's a good question. What happens is, as we go through the life cycle and the maturation system, that they slough off, just like flowers or dandelions. They blow away and they accumulate, and that debris then acts as a media for bacteria to grow. Once it kind of grows, blooms, and dies, it then accumulates in piping, and that then acts as a media for other bacteria to grow. Uh, but whereas in the rainwater system, it sloughs to the bottom of the tank, and we flush it out, and that keeps the water and the biofilm working in a positive manner.
Oh, great. Good explanation.
And again, this is kind of what I was talking about. It kind of breaks down
Hmm.
and seizes the biofilm elsewhere. Okay, biofilms can enhance microbial stability, but may clog filters and reduce flow. That's kind of what we just talked about. Monitoring EPS, and there was a definition of that I glossed over. That's the glue that goes around the microbes themselves. And then design choices influence the biofilm behavior. One of the problems that makes biofilm a bad thing in plumbing systems is that we're still using the same pipe sizing that they did back in the 40s and 50s, and yet we have high efficiency, low flow toilets and faucets and things like that. That gives the water more residual time in the type in the piping system, and gives it more time for the biofilm and things to kind of accumulate. As a
Hmm.
side note, again, we are in the process of revising our sizing parameters to decrease the pipe size to increase pipe velocity and move the water through the piping systems faster. Um, this is Billy Kniffen. Billy Kniffen, again, he worked with his church, and this is some of his story. That again, he's out of kind of where rainwater sort of started. Rainwater catchment started down in the desert Southwest in Texas, where water is a little bit more of a precious commodity. Um, and I'll just let you read his verbiage here. 80 to 85% of the water samples tested for coliform and bacteria, and even includes well water. Um, and, and you can see down below. Um, but this is a water sample test that if you look at it, uh, total coliform, basically, if you use some of the things that we're talking about, it gives a positive benefit to his rainwater catchment systems here. Um, these are some of the people that work with Billy, working in his missionary work in Africa and Tanzania. Um,
Wow. We would
um,
just install the system at the Maasai for tree bog. So we'll have to get in touch with them. We're right in the same
well,
area.
yeah, as a matter of fact, yeah, he talks about the Messiah here. This is one of his systems that Billy and his team put together. You can see over along the corner of the building here where the first flush is, and the sequential tanks that Muyan Han recommends. And these are the people drawing the water from um, yeah, which has been quite successful. And I'll put a underline on this as to the benefits. First flush, basically, and then basically filtration of the water to get as good a quality water going in as possible. Over here, you see where the first flush piping is, and then it branches off and it goes to the tank. Um, and again, the same thing, first flush over here, going to the tanks. Another project. Um, these are probably they took the tanks they had. We wouldn't recommend these white tanks because that allows sunlight to come through and allows algae to grow inside the tank, which is counterproductive. But again, they do what with what they have. Um, again, the primary school project. Again, showing the first flush devices and the tank. Providing for the entire community. Got school, and you can read that. 21 10,000 liter tanks.
Wow.
And basically moving water around their campus here.
Mm-hmm.
And this is the man on the ground there
Yeah.
leading the charge there. And apparently they pay off in goats in Africa, and so that's was kind of the men that were so appreciative that they contributed goats to the school project there. Um, Another project.
Mm-hmm.
And this was again the conference that I went to back in 2023 here in New York that introduced me to the international nature of the water scarcity issue. Um, this is where it gets kind of neat. This is I quizzed for a presentation. I quizzed Billy. He says, "Well, we really need to have a water quality sample that shows that this actually works." Um, and I got a little pushback on that, and there's interesting logic here as to why that is. Um, he basically goes on to say that the maintenance you need something fairly simple. Um, but maintenance is always an issue everywhere you go in the world. That you can come up with great designs, but it's the maintenance everywhere that makes the difference of whether you have a success or not. Um, uh, and again, some of the comments about it, favorable comments. Um, and this is basically old school here in the United States, where I'm at in the middle of the country. A lot of farmlands were kind of stretched out. Uh, a lot of farms beyond the city water. So this was kind of an early version of what we're talking about here. The first flush, basically, you let all the water just run out till you felt like water off the roof was clean, and then you flipped it over, and this is what went to your tank. So we're kind of reinventing the wheel and what we're recommending here with the first flush. This is a early sand filter that Billy Kniffen's actually mother-in-law used there in southern Indiana here. Um, and this is kind of another profile of a system that actually is more of a commercial version of how the sand goes down. They have a pipe that kind of comes up, it overflows there, keeping the water on top of the sand filter. And they uh, actually tried to make a commercial effort there in Africa by making them out of concrete, and they're still trying to make a market for those. But it's basically a sand filter, um, and this is some of the success of it there that we see. Um, I want to back up. One of the comments that the guy made, I apologize for this. The last comment at the bottom here is telling. Billy basically said that one of the reasons that they didn't want to get a water test because there was strong feeling against the local administration that the water they were providing was better than what the utility was providing, and they didn't want to rock the boat. So they kind of kept this under the hat, and
Oh,
that what they were doing was actually better than what local utilities were providing. And it's been quite successful, as you can see from um, we saw kids lining up
right.
to get their water. So, summary and conclusion: this is off of Muyan Han's things that contaminants, including microorganisms, are attached to the biofilm. Water quality is improved as biofilms are grown by nutrient degradation. And the 5 design and maintenance recommendations for successful use of a nature-based rainwater system are to maintain a clean collection surface from gutters and piping. That's what Peter Coombs recommended. Um, Acknowledging that that's a unique microbial ecosystem which can control the microbial quality uh, and And this is telling, and this is where I don't know if you recall the detail of Peter Combs. It's not a good idea to have the makeup air from your utility, particularly if it's chlorinated water, make up to your
Mm-hmm.
tank, because that is detrimental to
Biofilm.
the biofilm. Similarly, here we have shingles that are treated for biocides to keep mold from growing on top of the. And we had one guy call up and said he did everything that we told him, ARCSA told him to do, and yet it killed his tomato plants. And he was kind of mad until we found out that he was drawing his water off a shingle roof that was treated for had a biocide for mold control. So, yeah, you need to pay attention to your entire collection rainwater system.
Mm-hmm.
Design a filtration baffle and a quiet inlet that basically eliminates the water from being stirred up. Um, I didn't mention this, but we talk about uh, the vacuum overflow. What's common is basically they have a drain, or you take your water out 4 inches above the bottom of the tank, which is very common piping connection. And as you recall, the Peter Coombs data, that's just right above the anaerobic zone, which is kind of the worst of um, of the biofilm. The biology is occurring just right below where you're commonly drawing your water off, which again, we speak to the floating, the benefits of the floating outlet. Surface to ratio, again, the more surface you have to the volume, which gives the biofilm a better chance to grow, that's a positive thing. And then the punchline of it all is cleaning and disinfection of the rainwater tank seems to be counterproductive. You need to go ahead and let the biofilm grow. Um, but while keeping the best quality water going into the tank. Uh, and there you have it. So, any questions?
I'm sure Festus probably has some questions. I have just a quick question on schools. We talked about putting the sand filter or implementing that with the school, and the folks at Christian Relief Fund said that they've found it makes more sense to have a dual bucket filter in the rooms because of the break in the school time to potentially um, mid create a gap in the use of the system, which could that, I guess, as long as there's water still in the system, it seems like that biofilter would stay the same as long as it's flowing in and flowing out. What is your perspective on that for schools where you might have a gap in service or use?
A similar problem we had here is we had a civil engineer at Purdue University, which we did a project for them that was a rainwater catchment system. And he came in and he was wanting to prove a negative situation. And he came in and he came with this water test, and he said, well, you got this, that, and the other, and we asked him, well, when did you do it? Well, it was over Christmas vacation when the school was out.
Oh,
So the water had stood there for about over maybe a week or two.
mm-hmm,
Um, and with the rainwater system, you've got no residual. So the key thing is that you need to keep water flowing through your system to allow this. It's entirely possible that if you have uh, water dead in the pipes, that pipe probably could be growing bacteria, since again there's no residual after the fact. My
mm-hmm,
my friend Marcus, he points out the fact that when you um, claim that you're eliminating 99% of all the bacteria. Well, that one guy that's left he's the meanest of the lot, and he's got no competition. So you're not. It's not just because something says it's 99 or 98% effective. That's not a home free type situation. You still need to pay attention what's going on downstream of where your sanitation device occurs.
mm-hmm. Excellent. And Festus or Bernard, did you have questions for Bob?
Yeah, first of all, thank you very much, uh, Bob, for the detailed explanation, detailed information put together. Actually, this is very, very educative. I would really like to thank you for putting together all this. and I've learned a lot from your tutorials. Actually, fast flash. Actually, let me say this fast flash. It was my first time since I started working with Global Water Works and talking to Greg. It was my first time to hear about fast flash things. We never had this in our country. So when I saw these pictures, I'm getting several perspectives of how you can make fast flash different styles, and I really appreciate your input. So my question is just a little bit about this biofilm. Did you say it's not good to add chlorine to the tank? I just want to clarification. Is it wise
Well, when you
to
add the chlorine, you're basically likely killing the biofilm. So it becomes a design/maintenance issue. I guess you need to pay attention to what the water is doing coming out of the tank. If you have if your roof is dirty and your first flush is not being effective, um, your water quality may get out of hand, and you may be forced to use chlorine. And but then when you do that, you're kind of taking away the benefits of the biofilm. One of the
Mhm.
things that we've learned over the years is that people get resistant to their ambient bacteria, which is why, um, if it's you and your family and you have your water system, you kind of get kind of used to all your local bugs. But if in a public area like a school or a hospital where you get people coming from different communities that may not have that same resistance, that's when you need to kind of up your ante a little bit and use the maybe solar power to drive a UV sanitation station or perhaps try to implement sand filters, things like that, to kind of up the level of the water treatment. And that's something that's could stand to have a lot of research. At what level does the human body adapt to local bacteria? And that's a little out of my pay grade on that, just being an engineer.
thank you.
Well, and that is, I think the complementary information on the different end use treatments, Bob, that goes in that off-grid paper that you put together. We'll post that to the community with this. And Festus and I are aware of some like this simple chlorine drops that could go into the water after it's released that may not, disrupt the biofilm. But I think um, as Greg said, addressing first the critical needs for water was how we started with these systems, and people have innovated with some first flush and some leaf eater technology, which are harder to get into the country. So we're going to keep refining these steps, and your information was extremely helpful. We have another session, the prayer meeting, that you're welcome to stay for, but we're going to go to a different Zoom site. And what I'd like to do is set up a follow-up meeting where we get data involved, and maybe Heather, and talk about how we can share this knowledge in a way that people can interact with it and perhaps learn from these different examples. I know you wanted to see more examples of what we're doing. Would that work for you to set up a follow-up maybe next week or the week after?
Yeah, I'd be happy to help.
Yeah. And
Then,
amazing over.
if possible, if we can put it to be on Mondays, when we will not have another meeting, it can be good, or Wednesday, or Monday or Wednesday.
Uh-huh. Do you have a preference, Bob? Monday or Wednesday? I think you had a conflict on Monday, so we could do the Wednesday.
I think I'm good. Next week is looks like right now you get first dibs. It's totally
Oh,
totally clear.
great. We'll do Monday at this time. That works.
Okay, that will be
Okay.
great.
Yeah, and then I'll have this up, Bob. And thank you so much. A great overview, and we'll see if we can also get Heather involved. So
Yeah, and then one more thing before you close, Mary. did you get a copy of these materials?
The slides, if it's possible,
Yes.
if you could send the slides.
I could
Yeah.
do that. You know, I
Yes,
would like
you-
to tell you one story about chlorine. We worked I mean, chlorine in this country is like the one true religion for water sanitation. And the story goes that we have like 5 times more chlorine in our water than any place else in the world, and we don't have the best water. We did a solar project for a prison over in our adjacent state, Ohio. And within 9 months, all of a sudden, the copper pipe was eaten out.
Oh my
And we got called to task for it. So we show up, and what it was a prison and an adjacent old folks home. And outside was a well system, and it was basically being they injected chlorine, but it had but they now the old people were dying. I guess that's what old people are supposed to do. But the prisoners were actually losing their teeth from
Mm.
over injecting the chlorine, and that was basically what was rotting out the pipes was a high chlorine level in the water. So with our standards, both the standard 63 that I indicated earlier in this, we try to avoid the heavy chemicals because what we've learned is chemicals in the hands of amateurs can be kind of dangerous. That's for what it's worth.
Oh, very, very helpful. Thank you, Bob. Yeah. So this has been amazing to have your expertise here and summarize with Billy Kniffen's and the teams and the Peter Coombs and Moyung Han. So thank you for consolidating all of this great knowledge, and we'll reconvene next Monday and hopefully start to share and improve upon what has been started, so that everyone does have the fresh benefit of the rainwater.
If you can maybe forward any questions you might have. In other words, if you have some biology questions, I could ask my friend either Billy Kniffen or Marcus Linger to kind of sit in as well. That their knowledge runs a little bit deeper than mine does in biology and such.
Yeah, awesome. We'll do that. We'll put it together. So thanks again, Bob, and I'll sign off on this one, and we'll join the prayer group, and then see you next Monday.
All right. Cheers.
Thank
all.
you.
Yep.
You
Thanks.
too.
Okay.
Bye.